Imagine a world where your car doesn't become obsolete in a few years, where you don't need to upgrade because technology is outdated or maintenance costs have skyrocketed. Sound impossible? Not to those familiar with the revolution quietly taking place in Tesla's labs. What many haven't yet realized is that the company isn't just creating another electric car, it's completely redefining car ownership. While traditional automakers remain stuck in the business model of the last century, a radical shift is taking shape, and it has a name: Tesla Model 2. At just $90,197, this vehicle promises to break every rule we know about durability and affordability in the automotive world. But don't be fooled by the low price. Behind that price tag lies revolutionary engineering that can last decades, not the traditional 5 to 8 years we're used to. The fundamental difference lies in the construction philosophy. While conventional cars are designed to fail and be replaced, the Model 2 was designed to continually evolve. It's like a smartphone on wheels, but instead of becoming slow and outdated, it becomes smarter and more efficient over time. The revolution begins in electronic architecture. And here's the first big secret that traditional automakers don't want you to discover. A typical car has more than 100 independent electronic modules called ECUs, each with its own personality and way of communicating. It's like having 100 different people trying to speak different languages at the same time. The result is confusion, conflict, and constant failures. These modules require miles of wires to connect, creating a complex web that is heavy, expensive, and prone to problems. The Model 2 ditches this approach and embraces something completely different: a centralized system powered by artificial intelligence, powered by the Dojo supercomputer. Imagine all that electronic clutter replaced by a single, ultra-intelligent brain that controls everything harmoniously. It's no longer 100 voices shouting, but a perfectly coordinated symphony orchestra. This centralization dramatically reduces internal wiring, eliminating single points of failure and simplifying the entire system. It's like trading a house full of messy wires for a smart home with Wi-Fi in every room. But the real magic happens when this artificial brain begins to learn about your driving behavior, your preferences, and even the vehicle's wear patterns. The system doesn't just react to problems, it anticipates them. Sensors throughout the car continuously collect data, creating a complete map of the vehicle's health. When a part is about to fail, the system already knows and can take preventative measures, or even order a replacement part before you even realize something is wrong. OTA, over-the-air updates, completely transform the ownership experience. Remember when you bought a car and it stayed exactly the same until the day you sold it? Those days are over. The Model 2 receives regular updates that can improve range, add new features, optimize motor performance, and even teach you new self-driving tricks. It's as if you bought a car and it magically became better every month. It's not science fiction. It's real technology applied intelligently. The savings generated by this approach are impressive and go far beyond the initial purchase price. Fewer components mean fewer things to break. Simpler systems result in cheaper and faster maintenance. Remote diagnostics eliminate many unnecessary visits to the repair shop. The car literally tells you what's going on through your smartphone. When maintenance is actually needed, the technician already knows exactly what the problem is and which parts to bring, reducing repair time and labor costs. The environmental impact of this philosophy is also revolutionary. A car that lasts decades instead of years means fewer natural resources consumed, less energy expended in production, and fewer vehicles scrapped. The modularity of the system allows parts to be replaced individually when needed, rather than scrapping entire systems. This is real sustainability, not just green marketing. The Model 2 isn't just a cheaper car, it's a long-term investment that completely redefines the economic equation of personal mobility. The heart of this technological revolution beats through something few fully understand: Zonal design. While traditional cars rely on a complex network of wires that run like veins throughout the vehicle, the Model 2 takes a radically different approach. Imagine the difference between an ancient city with narrow, confusing streets versus a modern metropolis with wide, well-planned avenues. The zonal system works exactly like this. Instead of hundreds of individual wires running from point to point, intelligent zones process information locally and communicate through a high-speed network. This architectural change results in an impressive 87% reduction in the vehicle's internal wiring. To understand the true impact of this transformation, consider that a traditional car carries approximately 5 kilometers of wires. That's right, 5 kilometers of copper snaking through the chassis. In the Model 2, this amount plummets to less than 650 meters of main cabling. The weight savings are substantial, but the true benefit goes beyond the numbers. Fewer wires mean fewer points of failure, less electromagnetic interference, and a much cleaner architecture for diagnostics and repairs. Communication speed between systems leaps to a whole new level. While traditional protocols like CAN bus operate at speeds we would consider slow today, the Model 2's neural system processes information up to 20 times faster. This difference may seem technically complex, but in practice, it means the difference between life and death in emergency situations. When the system detects an obstacle ahead and needs to apply the brakes, every millisecond counts. Ultra-fast communication allows the artificial brain to make decisions and execute actions at speeds that far surpass human reflexes. But speed without intelligence is useless, and this is where the real difference comes in. The zonal system doesn't just transmit data quickly. It processes it locally before sending only the relevant information to the central processor. It's like having multiple intelligent assistants spread throughout the car, each handling its own specific area, but all connected to the same boss. The result is impressive computational efficiency that enables advanced functionality without overloading the main system. The self-diagnosis capability becomes almost supernatural with this architecture. The car doesn't just detect when something is malfunctioning, it can isolate the problem with surgical precision and, in many cases, correct it automatically. Sensors distributed throughout each zone constantly monitor temperature, vibration, electrical current, and dozens of other parameters. When values deviate from the normal range, the system doesn't just record the problem, it analyzes the possible causes, checks related systems, and implements fixes where possible. Over-the-air updates gain transformative power in this environment. Unlike traditional cars, where a software update requires connecting specific cables to individual modules, the Model 2 allows improvements to be implemented in a coordinated manner across the entire system. A single update can simultaneously optimize motor performance, fine-tune steering response, improve battery efficiency, and add new safety features. It's as if the car were completely digitally rebuilt overnight. While you sleep, predictive maintenance reaches levels of sophistication bordering on science fiction. The system learns the normal operating patterns of each component and detects deviations long before they become visible problems. Brake pads that begin to show microscopic signs of wear, bearings that exhibit barely perceptible vibrations, electrical connections that begin to develop resistance. Everything is monitored and analyzed. The car can literally schedule its own maintenance and order parts before any failure occurs. The recyclability and modularity of the zonal system completely transform the vehicle's life cycle. When a specific zone needs updating or repairing, it can be replaced individually without affecting the rest of the system. It's like replacing just one diseased organ instead of discarding the entire body. Electronic components can be reused, remanufactured, or recycled much more efficiently, creating a true circular economy in the automotive industry. Model 2 isn't just smart, it's sustainable by design, prepared for a future where resources are precious and waste is unacceptable. The battle against heat has always been one of the greatest challenges in automotive engineering. But in the world of electric cars, this war takes on epic proportions. The difference between a battery that lasts 8 years and one that functions perfectly for 15 years or more is hidden in a few degrees Celsius of temperature. What few realize is that each battery cell has a very specific thermal comfort zone. Going outside of it means accelerated degradation, loss of capacity, and drastically reduced lifespan. The Model 2 not only understands this complex science, but completely masters it through innovations that would astound engineers of previous generations. The adaptive thermal system represents a massive evolution over traditional automotive cooling methods. While conventional cars use dumb cooling systems that simply circulate liquid when temperatures get too high, the Model 2 employs more than 50 temperature sensors strategically placed throughout the vehicle. These sensors don't just measure, they create a three-dimensional heat map in real time, identifying hot spots before they become problems and cold zones that can be leveraged to optimize the overall system. The artificial intelligence behind thermal control works like a conductor conducting a complex orchestra of pumps, fans, valves, and heat exchangers. The system predicts thermal needs based on driving style, weather conditions, route topography, and even the time of day. If you're climbing a mountain on a hot day, the system begins preparing before the battery temperature begins to rise. If you're driving on a flat road at night, it reduces active cooling and uses natural air to keep everything at the ideal temperature. The introduction of the aluminum-ion battery marks another impressive technological leap. Unlike traditional lithium-ion batteries, which are temperature-sensitive and demanding, aluminum cells operate more stably across a wider temperature range. But this doesn't mean thermal control becomes less important. It means it can be even more precise and efficient. The system can keep each battery module at the perfect temperature for maximum efficiency, resulting in a 17% longer lifespan and up to 60,000 additional kilometers of total range. Intelligent thermal management isn't limited to the battery. It optimizes the vehicle's entire energy ecosystem. Electric motors, which can generate significant heat during intense acceleration, are proactively cooled. Inverters, responsible for converting direct current from the battery into alternating current for the motors, operate at optimal temperatures that maximize their efficiency. Even the cabin air conditioning system is integrated into the overall thermal management, harnessing the residual heat from components to warm the interior in winter. The energy savings resulting from this precise control are impressive. Cooling energy consumption has dropped by 18% compared to previous systems, which directly translates into additional range. Every kilowatt-hour saved in the thermal system means up to 17 extra kilometers you can travel on a single charge. In practical terms, this represents the difference between reaching your destination or being stuck on the road looking for a charger. Extreme climate adaptation is made possible by sophisticated algorithms that learn the specific environmental conditions of each region. A Model 2 operating in the Arizona desert develops completely different thermal strategies than one operating in the Canadian winter. The system monitors local weather patterns, learns from previous experiences, and proactively adjusts its parameters. In extreme heat, it can pre-cool the battery using grid power before you even get in the car. The impact on battery durability goes far beyond impressive lifespan figures. Cells that consistently operate at the ideal temperature maintain stable internal chemistry for much longer. This means less capacity degradation, faster charging over the years, and more consistent performance even after thousands of charge and discharge cycles. Model 2 doesn't just promise a longer-lasting battery. It delivers an energy system that ages gracefully, maintaining its youthful performance characteristics for decades. Sensor visibility is the blind spot that can turn even the most sophisticated autonomous technology into a disaster waiting to happen. Imagine having the best eyes in the world, but being unable to see because they're constantly dirty or foggy. This is exactly what happens to driver assistance systems when cameras, ultrasonic sensors, and radars are compromised by dirt, rain, snow, or even everyday dust. What seems like a simple problem becomes an engineering nightmare when you need to ensure these electronic eyes function flawlessly in any weather condition, 24/7. The Model 2's self-cleaning system represents an elegant solution to a problem that has plagued engineers for years. Instead of relying on mechanical methods like traditional wipers or brushes, which can scratch delicate lenses or fail in extreme conditions, the vehicle employs strategically placed jets of compressed air. These jets are activated by an artificial intelligence system that constantly monitors the visual quality of the sensors. It's like having a dedicated assistant that cleans your glasses whenever it detects your vision is becoming compromised, but does so thousands of times faster than any human could. The sophistication of the dirt detection system goes far beyond what one might imagine. Specialized light sensors analyze the quality of the image captured by the cameras in real time, identifying patterns that indicate obstructions. The system not only detects obvious dirt, like mud or snow, it even identifies microscopic dust films that can reduce visual clarity by just a few percent. Image processing algorithms constantly compare the current visual quality with reference standards, triggering the cleaning system when they detect degradation above pre-established thresholds. Field tests have revealed impressive figures regarding the system's effectiveness. Under controlled laboratory conditions, sensor visibility restoration reaches 96.4% after a full cleaning cycle. But the true test comes in the real world, where acid rain, sea salt, pollen, insects, and dozens of other contaminants create unique challenges. The system learns from each situation, adjusting air pressure, spray duration, and cleaning frequency based on the type of dirt detected and specific environmental conditions. Integration with autonomous driving systems transforms this functionality from a convenient luxury into a critical safety necessity. When Model 2 operates in autonomous mode, it must process visual information with absolute precision to make split-second decisions. A partially obstructed front camera can mean the difference between detecting a pedestrian in time to brake or not seeing them until it's too late. The self-cleaning system literally becomes a matter of life or death, ensuring that the sensors maintain their maximum visual acuity regardless of external conditions. The operational savings of this system are substantial when considered over time. Owners of vehicles with conventional driver assistance systems often have to manually clean cameras and sensors, or worse, find their systems malfunctioning just when they need them most. Model 2 eliminates this concern by keeping all sensors constantly clean and functional. This significantly reduces maintenance costs related to sensor cleaning and calibration, while also avoiding the potentially catastrophic costs of accidents caused by compromised safety systems. Reliability in extreme conditions sets this system apart from improvised or stopgap solutions. During snowstorms, compressed air can remove ice buildup that would otherwise completely block the sensor's view. In desert regions, where sandstorms can cover a vehicle in minutes, the system keeps the sensors functional even when the rest of the car is completely covered in dust. This ability to operate in adverse conditions is fundamental to Tesla's promise of truly reliable autonomy. The impact of this technology goes beyond immediate functionality. It represents a crucial step toward full vehicle autonomy,